Okay, so if we want to evaluate this function when x equals -3, all we need to do is plug in -3 for x. So we'd have 4 times -3 to the third power minus 5 times -3 squared plus 2 times -3 minus 4. And we could type it into our calculator or evaluate it by hand, either way. So we'd have 4 times -27 minus 5 times 9, and then minus 6 minus 4. And then we would end up with -163. Alright, so to simplify this, the first step would be to distribute everything and get rid of the parentheses. So we have 3x squared plus 6 minus 10x squared minus 15x plus 20 minus 2x squared minus 8. And then we would just need to combine like terms. And we would get C. Okay, so if we want to find all the zeros, we need to completely factor this. So hopefully looking at x to the fourth minus 1, you see it's a something squared minus something squared, so we can factor it to x squared plus 1 times x squared minus 1. Now the x squared plus 1 we cannot factor anymore, but the x squared minus 1 again is something squared minus something squared, so it factors to x plus 1 times x minus 1. So if we go ahead and solve the x squared plus 1, you subtract 1 from both sides. I'll get it all set up first. So we'll set all those to 0, subtract 1, and then we're going to have to take the square root of both sides. So the square root of -1 is I, so we have x equals plus and minus I. With x plus 1, we just got to subtract 1, we get x equals -1. And then we'd have to add 1, and we get x equals positive 1. So we found all 4 roots, 2 of them are real, 2 are imaginary, so the answer is D. Okay, so we need to completely factor this in order to get it simplified. One rule we're going to need here is what we have when we have something cubed minus something cubed. And it factors to the a minus b times a squared plus ab plus b squared. So to start off with, we're just going to look at the numerator and get it factored. So hopefully you realize that there is a x as a GCF. So now we've got x squared minus 4. So now that factors to x plus 2 times x minus 2. Alright, so now we need to take a look at our denominator. Hopefully looking at those, you see they both have an x squared in common, so that'll be the first thing we factor out. And now we've got x cubed minus 8. Well, that is something cubed minus something cubed. It's x to the third minus 2 to the third. So now we can use this rule up here, and our x is our a, and our 2 is our b. So we got x squared times x minus 2 times x squared plus 2x plus 4. So now if we look at both these, we put our numerator on top, our denominator on bottom, we'll see what we can, what reduces to 1. So hopefully we see that an x minus 2 reduces to 1, and that we have an x on top and an x on bottom. So our answer would be D. Okay, so hopefully remember that area equals 1/2 the base times the height. So they gave us one of the legs, so we know that the area is 1/2 x squared minus 5x plus 12 equals 1/2 x minus 4 times the height, or the base. I guess that's how I wrote it. So now what we want to do is try to get b by itself. So we're going to multiply everything by 2. Get rid of that 1/2. And now we've got x squared minus 10x plus 24 equals b times x minus 4. So now we just need to divide both sides by x minus 4. Alright, so this would be a great situation to use synthetic division on, because we can easily solve this with minimal work this way. So remember, the first number we put down is what makes x minus 4 0. So we have to put a positive 4 down. With synthetic division, you always have to write the opposite. And then we just set everything up. We write our coefficients out, 1, -10, and 24. Remember, we just bring the first one down, then we multiply and add. So we get -6, multiply, 4 times -6, get -24, add, get 0. So we can see that this divides in evenly. So our answer would be x minus 6. Remember, we start with 1 power less. So the answer would be B. Alright, so to completely factor this, we've got to pull out the GCF. We have a 2x in common, so we'll factor that out. And we're left with x to the 4th minus 29x squared plus 100. So now we just have to ask ourselves what two numbers multiply together to give us 100 but add up to be -29. So we break apart our x to the 4th. We got x squared minus 4 and x squared minus 25. Now we can break this down even further because we got something squared minus something squared. And now we have it completely factored. The answer is D. Okay, so how many real zeros? We could just type this into our calculator and hit graph. And we can actually see them. Now I also changed the window here just to zoom it out, just to make sure there's nothing happening out really far. But we can see there is only one real zero. Okay, so possible rational solutions. We're going to have to use the rational root theorem here. And it's pretty easy to use. So the first thing we want to do is we want to get this thing equal to 0. We've got to have everything on one side. And when we do, our answer would be plus or minus, and then all the factors of the constant term over the factors of the coefficient in front of the biggest power of x. So if we go ahead and subtract 2 from both sides, this is what we would have. Now, we might as well just go ahead and multiply everything by 2 just so we can have a nice neat 1 as the leading coefficient. Again, the only two things we're worried about is the coefficient in front of the biggest power of x and the number by itself, the constant. So the factors of 4 are 1, 2, and 4. So we write those on the top. The factors of 1 is just 1. So we have plus or minus 1, plus or minus 2, and plus or minus 4. Those would be the possible rational solutions for this. The answer would be Alright, so hopefully when you guys look at this, you're thinking back to the polynomial work we did. We've got a double root right there, so that crosses once. And if we solve that, we're going to get two imaginary solutions for that one. And then we've got one triple root. So we actually only have two real roots here. Alright, so if we want to represent this graph, we want to basically write an equation so all those values are 0. And if you look, there's no double root, so we can know a and c aren't it. But negative a, x plus a would make that 0. Positive b, x minus b would make that 0. X minus c, and x minus d. So if we look at that, D would be our correct answer. Alright, so if we're going to completely factor this, we would want to start off and pull out the GCF. They have a GCF of 2xy. That doesn't help us eliminate anything though. And we end up with 64x to the 6th plus 16x cubed y cubed. And then y to the 6th. So now we can factor this. So we'd have 8x to the 3rd, just cut it in half, plus y to the 3rd power. So 8x cubed plus y to the 3rd power. Perfect square trinomial. Now we have to go back to the sum of cubes again, because we've got something cubed plus something cubed. So when it's addition, it would factor to a plus b, a squared minus ab plus b squared. So if you think about rewriting this, we would have 2x cubed and y cubed. So the a value is like 2x and the b value is y. So using that rule, we know we're going to have 2x plus y, and we're going to square it because we got two of them. And then we're going to have 4x squared plus 2xy plus y squared. And we're going to have to square that as well because we had two of those 8x cubed plus y cubes. So our answer would be C. Alright, so we can go through and solve this by hand or just graph it and do the zero function and see if they're rational or not. So that one's too imaginary, so we don't have to worry about that. And then if we look at the value of the discriminant here for the quadratic part, if we get a perfect square here, we know that it would be a rational solution. But if it's something that's not a perfect square, it's going to be an irrational solution. So we get 24, so we know that's going to produce irrational solutions. So the only solution, rational zero that we have is positive 4. Okay, so rational roots here. We can use the calculator, hit graph, and use the zeros and see what we get. We know it wouldn't be C because that one's got irrational numbers as an answer. So we'd want to check to see if it crosses at -1 and 1, which it does. It doesn't cross at 3 and -3. We could have also factored this. Okay, so with this one, you have to actually create the factored form, and then we're going to need to multiply it out. So since we know it crosses at 3, or we know it would be x minus 3. And since it crosses at 3 minus I, we know it would be x minus 3 minus I. And we would also know the conjugate of that would be a solution, so we'd have x minus 3 plus I. And now we would just have to go through and use the box method a couple times and multiply this out. So we have x squared, and then negative 3x plus xi, and then we'd have negative 3x minus xi, and then we would use the box method or FOIL, and we can multiply negative 3 plus I times negative 3 minus I. Notice the inner and outer terms will cancel each other out. So really we're left with 9 minus I squared, which is really just 9 plus 1, so we'd have a 10. So now we have to take our solution from this and multiply it by x minus 3. So we'll set the box up. Then we'll go through and multiply everything out. And then we can combine our like terms. We'd have x cubed minus 9x squared plus 28x minus 30. So our answer would be C. Alright, so with this one, the easiest thing to do would be to type it in and graph it on your calculator and look and see where that root is actually at. Is it between negative 1 and 0, 0 and 1, 5 and 6, or 8 and 9? So when we graph it, we can see that it crosses in between 0 and 1. And then I just threw this problem in here. So we didn't do a long division problem where we divided by a quadratic. So I just worked this out for you so you can see how it's done.